Hello everyone, welcome back. So let's do a brief recap of what we talked about in the last video. In the last video, what we did is we tried to make this angle dependence for my boomerang. And we want to make it vary depending on the angle that the boomerang tower is facing. So if we go ahead and click play to see the preview, we want to vary it depending on where my tank is, which affects where my boomerang tower aims at. So this seems weird. Okay, it's going, that seems correct. Doesn't seem correct. What's going on? And what exactly is this doing? Well, if we look at our events, we are taking the cosine of the angle and multiplying it by the firing range and adding that to the cannon position to make it move all the way to the, let's go ahead and see if we can get it correct. To make it move all the way to the furthest position it can. Alright, that's for the X value. For the Y value, we're adding to the cannon position the firing range times the sine of the angle. Now, what exactly does that do? Well, if we learn the unit circle, this is a pre-cal concept, I believe, then we would see that, sure, Wikipedia, let's go ahead and try that out. We will see that the sine of the angle, the max value is 1, and then becomes negative. Then becomes 0, -1, 0. The cosine of the angle is the x1. It's 1. Cosine 90 is 0. Cosine 180 is -1. Cosine of 270 is 0. And there are values in between, with the y value being the sine and the x value being a cosine. So yes, video game design does require some math, a lot of math actually. So we tried getting this 1 to -1 variance to affect exactly how far up the x and y the boomerang travels. But for some reason, it's not quite working. Why is that? Well, let's see. So is the range working? Kind of. Okay. Maybe. So let's go ahead and try to debug this problem. Now to debug this problem, I went ahead and looked at some other ways of showing the values. Basically, we want to see the value that this is returning. How can we do that? Well, we can do that with a text object. So I'm going to go ahead and make a text object. I'm going to go ahead and call this maybe angle. And the text will be angle is something. I'm going to drag this on, and I'm going to modify this text. Now, it doesn't matter where you modify it. I'm just going to make an event. I'm going to put at the very bottom. There's no condition. It's always going to be running. I'm going to set the text object to be a value. So modify the text of a variable. Not really. I want to modify the text. Let's look for that text object. There we go. I want to modify the text. Now, what do I want this text to be? I want to modify the angle text object. I want to set it equal to some text. What text do I want? Well, I want it to be the angle. So if I go back to my event, I want this to be equal to the angle of my boomerang tower right here. Okay, I'm gonna go ahead and minimize this since we don't need it. So how do I get that boomerang tower angle? Well, let's go ahead and look. Let's see if I can. Nope. Common expression for all objects. Object name. Object variable. It's not really an object variable. Scene. It's not a scene name. Conversion. Number of text. Can't do this. Maybe. Will that work? Well, let's try it out. Hey, it works. Kind of. But it doesn't really say angle. So, but we know that this is the angle, okay? And you can see the angle. So right here is 0. And then we go to negative 90, which should be about vertical. Right? This boomerang tower should be vertical. And we get to, okay, so we have like a negative 179, and we, boom, pop to 179 positive. And then we get to a positive 90 down here. And we get to 0 somewhere here. Alright, that's a little interesting, because didn't this say that the angle is 0, 90, 180, 270? Why is this negative 90 all the way to negative 180 essentially? Well, if you recall from the unit circle, even 270 can be considered negative 90. Because the typical way we rotate for a unit circle is counterclockwise. And that's positive. But if we do a negative, then we do clockwise. Similar concept. But this diagram does kind of lie a little bit, I guess, to what results we're getting from our thing. Alright, now that we have the angle, let's go ahead and make text objects to have the sign of the angle. Okay. So, sine angle. Let's go ahead and make another one for the cosine of the angle. And let's drag them on. So something's not quite right. And let's go ahead and add an event. We can just copy this. And I want to do it the sine of this. Okay, and I want to be not the angle, sine angle. Let's go ahead and check that out. Alright, so what the heck is happening? So let's go back to my unit circle. It should be 0 to 1, 0 to negative 1, or something along those lines. But if I look here, this one is angle, this one's sine of angle. The sine of 0 should be 0 about, but why is it so close to negative 1? And then why is my sine of my angle, which is this value, changing so drastically? It should now just be approaching negative 1 or 1. And it should now be 0. Okay. But for some reason it's this number very close to negative 1. I wonder if my cosine is doing the same thing. I'm going to go ahead and copy this event and paste. So instead of doing sine, I'm going to do cosine. And I'm going to use the cosine. Alright. So cosine of this should be 0. But it's about 0.63. This should be positive 1, but okay. Pretty close to positive 1. But why has it suddenly become negative all of a sudden? It's not right. Why is it changing like this? It's obviously not correct. Well, maybe I missed something. Let's see. In order to move or rotate objects, you would need to specify the desired angle in degrees. See below. Okay. If you use trigonometric functions like the sine or cosine, note that you will have to express angles in radians. Oh. So currently what's happening is that if I look here, my angle, BoomerangTower.angle, that's returning the angle in degrees. So if I look here, this top one, 0 degrees, 90, 180 degrees, and it goes to negative 90, which is basically 270, and then back here. That's in degrees. But this documentation is saying we need to express that in radians. So how do we convert degrees to radians? Well, it says 1 radian is 180 divided by pi degrees, and 1 degree is pi divided by 180 radians. Pi being number approximately 3.14159. Okay, if you don't know what any of that meant, that's okay. Let's go ahead and search. What do I want to search? I want to convert degrees to radians. Convert degrees to radians. So, let's go ahead and put, I don't know, 90. So what I need to do, I need to multiply my degrees by pi, which they said is approximately 3.14159, and then divide it by 180, and then I get the radians. Okay, let's try that. So, up here, now this is very long, but this is my angle in degrees right here. I'm going to go ahead and multiply that by, what was it? Pi 3.14159 times 3.14159, then divide it by 180. Put the same thing there. So I'm going to get the angle, BoomerangTower.angle, multiply that by 3.14159 divided by 180 to convert it to radians, take the sine of all of that to get a number between -1 and 1, and then multiply that by the firing range. Alright, let's see how it goes. Awesome. My boomerangs seem to be tracking pretty well. Yep. Awesome. And these numbers aren't quite accurate. What I need to do is, if I want them to be accurate, I need to multiply this angle by 3.14159 divided by 180. Let's copy that. Same thing here. And let's go ahead and check. Alright, so now this is cosine of 0 is about 1. We see right here. Sine of 0 is about 0. Then we go to -90 angle. Sine of -90 is about -1. Sine of -90 is about 0. Right here. Sine of 180 is about 0. Cosine is about -1. cosine of 90 positive is about 0. Sine is about 1. Awesome. We fixed our angles and we got everything to work. Awesome. The next video will have a quick demonstration of another way to go ahead and do this text object thing. It is a little bit more complicated. It's not necessary, but I hope this showed you the importance of math and being able to figure things out and troubleshoot things. And I'll see you in the next video.